Hello and welcome to another episode of TWiML Talk, the podcast where I interview interesting people doing interesting things in machine learning and artificial intelligence. I'm your host, Sam Charrington. As many of you already know, one of the exciting parts of my work involves keeping tabs on the way large companies are adopting machine learning, deep learning, and AI. While it's still fairly early in the game, we're at a really interesting time for many companies. With the first wave of ML projects at early adopter enterprises starting to mature, many organizations are now asking how they can scale up their efforts to support more projects. Part of the answer to successfully scaling ML is supporting data scientists and machine learning engineers with modern processes, tooling, and platforms. This is a topic that we're super excited to address here on the podcast with the AI Platforms podcast series that you're currently listening to, as well as a series of ebooks that we'll be publishing on the topic. The first of these ebooks takes a bottoms-up look at AI platforms and is focused on the open source Kubernetes project, which is used to deliver scalable ML infrastructure at places like Airbnb, Booking.com, and OpenAI. The second book in the series, which looks at scaling data science and ML engineering from the top down, explores the internal platforms companies like Airbnb, Facebook, and Uber have built and what enterprises can learn from them. If this is a topic you're interested in, I'd encourage you to visit twimlai.com/AI platforms and sign up to be notified as soon as these books are published. In this episode of our AI Platforms series, we're joined by Atul Kale, engineering manager on the machine learning infrastructure team at Airbnb. Atul and I met at the Strata Data conference a while back to discuss Airbnb's internal machine learning platform, Bighead. In our conversation, Atul outlines the ML lifecycle at Airbnb and how the various components of Bighead support it. We then dig into those components, which include Redspot, their supercharged Jupyter notebook service, DeepThought, their real-time inference environment, Zipline, their data management platform, and quite a few others. We also take a look at some of Atul's best practices for scaling machine learning and discuss a special announcement that he and his team made at Strata. And now, on to the show. All right, everyone, I am in New York City here for the Strata conference, and I've got the pleasure of being seated with Atul Kale. Atul is an engineering manager at Airbnb on the machine learning infrastructure team. Atul, welcome to This Week in Machine Learning and AI.
Thanks, Sam. Thanks for having me. It's a pleasure to be here.
So yesterday you did a presentation on Airbnb's machine learning platform, which is called Bighead. It was a great presentation, and I'm really looking forward to diving into some of the details with you. But before we do that, how did you get into ML and AI?
Yeah, sure. So I'm trained as a computer engineer. I went to the University of Illinois, and right out of college, I actually started my career in the trading industry at a firm called DRW Trading. And DRW, they're a proprietary trading firm, so they, trade their own money for their own profit. They don't have any customers. And, you can imagine for a trading firm like DRW, it's really important to have a data warehouse that's stocked full of information about the financial markets. So imagine, you're working on, a particular trading strategy, and you need something kind of like TiVo for the markets, right? So you need to be able to understand at a very fine granularity exactly what was going on a particular exchange or in the markets for a particular instrument. So my first job at DRW was to create that data warehouse, everything from kind of the basic ETL and even like the data capture and all that sort of stuff, as well as like that backend database that's required. But then after I completed working on that, I made a transition towards working on trading strategies. And that's kind of where I got more into machine learning. So we went through kind of two different trading strategies. One was kind of light on the machine learning, and one was really heavy on machine learning. And in that latter one, I started really focusing on infrastructure. I think in general, my background is in backend work and infrastructure engineering. So that's really, where my passion is. And for the trading strategies that we were working on, we really needed a high degree of automation and sophistication around training our models. So I spent quite a bit of time working on building infrastructure for my individual team. And then, about a year and a half ago, I was kind of looking to make a transition, and I got a good opportunity at Airbnb, working on their machine learning infrastructure team, kind of combining this passion for infrastructure with the interest I have in machine learning. So I've been working there for about the last year or so, and I'm currently leading the team.
The way you explained the motivation for Bighead in your presentation, I thought was very well put. You talked about this notion of inherent complexity and incidental complexity. What are those?
Right. Yeah. So I think the term that we use is intrinsic complexity and incidental complexity. We kind of just made these terms up. But the idea is pretty simple, that the intrinsic complexity with machine learning is all about, kind of understanding the latest modeling techniques, picking the right model, picking the right features for your model, and then really fine-tuning that. Machine learning in some ways is kind of an art of, really understanding your problem domain and fitting the right models to it. And that's really what we found that our ML practitioners at Airbnb, by that I mean the data scientists and engineers that are working on deploying ML in our product, we found that they're really interested in solving those problems. But on the other hand, there's this other side of getting a machine learning project off the ground, and that's incidental complexity. That's what we call it. And that has to do with all the messy details of getting access to your data warehouse, and then making sure that what you prototype with is, what is consistent with what you actually go into production with. And, just having consistency also between your trained model and what you're going to actually see in production at inference time, for example. So there's a lot of messy details there. You also have to deal with managing all the various experiments that you've got, the versions of your model, and all of that just adds up to a lot. What we found is that when teams were having to deal with intrinsic complexity and incidental complexity together, that's just overwhelming for them. And a lot of teams at Airbnb were just not even that interested in machine learning, just because the cost of it was so high.
So part of the goal is to reduce the barrier to entry so that a greater proportion of teams could incorporate machine learning into what they're doing.
Exactly. Yeah. I mean, our goal as a team, the machine learning infrastructure team, is really to scale ML at Airbnb. And in order to reach that goal, of course, we're going to need to reduce the barrier to entry. So that's really important to us.
How did it evolve? Was it initially a collection of specific tools that solve specific problems, or was it architected from the beginning as kind of a broad platform?
Oh, yeah, definitely we did not get this right from the start. I think that, as with many products, it's just cycle of iteration and, lessons learned, and then applying those lessons learned and building something new. So the history for us specifically is that, Bighead's components, sort of the subcomponents of Bighead are they're pieces that Airbnb had kind of collected over the years, all to solve, really specific problems with machine learning, with getting machine learning into production. And we found that was kind of piecemeal. Of course, those problems were solved, sometimes not in the most sustainable way, but solved nonetheless. Mm-hmm. But then, when we looked at the entire system and we looked at the shortcomings, the problem was really that it wasn't cohesive. All these piecemeal components didn't really fit well together. So Bighead was an attempt to kind of make one more pass over the entire system, the entire architecture, and really focus this time on cohesiveness and end-to-end consistency.
Maybe let's walk through the various components of the system. Where do you start? Or you went through this in your presentation yesterday. What was the first component that you presented?
Yeah, sure. So we start with where our users start, right? So our users need to prototype. They need kind of a development environment for machine learning. And for that, we have Redspot, which is really just a Jupyter notebook service. It's Jupyter Notebooks as a service. But, they're really not just, the same as running a notebook on your laptop. It's pretty high powered. You can plug it into more or less, any EC2 instance type on AWS that we have available. So you can get access to things like GPUs and really high memory instances. So you can be kind of unblocked to get your work done. But then in addition, it's really cleanly integrated into our data warehouse so that you have access to all the wealth of data that's going to actually make your machine learning project powerful.
Yeah, one of the things that I've run into just with personal experimentation is you choose an instance type, you start running some experiment, and then you realize that you get to a point where you wish you had more hardware. Like, have you managed to decouple the notebook itself from the underlying infrastructure?
Yeah, that's a great point. I think this is actually something that we're looking to address in the future. It's not just that you might not know exactly what hardware you need, but also it's pretty inefficient rather, for every user that might need to train a deep neural network to fire up a 8 GPU machine and have it sitting around for weeks maybe while they tinker around with their model, right? So that's definitely an area of concern. You can't vertically scale individuals' development environment for long. So what we're doing, and this is kind of on our roadmap, is to build out what we're calling BigQ right now. Okay. The idea is that your notebook environment can then become really thin, and instead what you do is you just submit your job for training your model off to a work queue that's powered by GPUs or potentially the latest in distributed training algorithms, something like that. This is sort of a follow-on to the rest of our infrastructure, where the goal is to really neatly encapsulate models. Once we have that powerful abstraction, now we can create these high-power tools like BigQ, where we understand enough about your model that we can train it really efficiently. So it's definitely kind of out there on our roadmap. And I think it was one of those things where we took an initial stab and we looked at our user base and we said, well, yeah, this kind of works for most people. And so it's definitely kind of minimally viable there, but we have a lot of plans to make that more efficient.
Mm-hmm. And then underlying the notebooks, all of the code is stored in Git repositories. And is that transparent to the user, or is the user kind of manually checking things in, checking things out? The user is indicating that they want to check things in, but have you built kind of in UI into the notebook experience where they're doing that, or they're doing that kind of traditionally?
They're doing that more traditionally. Yeah. I think that we can try to hide away some of the details of version control, but ultimately, it's kind of just a complicated, messy process. Yeah. Version control in general. So we don't really want to try to reinvent the wheel on that. What we focus on is just making sure that it's easy to get your notebook or Python code into production, and that it's neatly versioned just like any other production code.
And now Python code typically has, or the notebook code typically has annotations and other types of artifacts that you don't necessarily want to, they're there for experimentation, but they're not there for, when you're actually trying to put a model into production. Do you separate those somehow? Yeah.
So I think, just to start, I would say that we don't necessarily focus on notebooks. We really just treat notebooks as Python code. And what we do is pre-process those notebooks to kind of strip out the annotations and strip out some of the exploratory work that you might be doing while you're prototyping. And right now, of course, that's pretty simple. You just have to tag your notebook cells as a prototype or not, and we just strip them out. Maybe, who knows, we'll come up with a machine learning model to do that automatically or something. But yeah, it's pretty much manually tagged for now, and we've actually been doing that for a while, and it seems to work reasonably well. But I think that one thing to note is that notebooks are kind of a mixed bag. On the one hand, you've got this ability to annotate things, to show your work, and to really show the process of experimentation. And that's great for machine learning projects where, especially when you get to kind of code review time, what you're reviewing when you look at somebody else's project isn't really just their code. You're reviewing kind of their thought process, their experimentation process. So it's almost kind of more like a research paper or something like that than it is just, a normal code review. So notebooks are great for that. What they're not great for is kind of the traditional software engineering process. Composition isn't great. Of course, you can jam all of your code right into the notebook, but a lot of times we find people repeating themselves. And testing, unit testing, this is super important for software engineering, but it's equally important for some of this machine learning code. And I think we're trying to strike the right balance between having those really solid software engineering practices, as well as having that flexibility of the notebook.
So what's the next component?
So next up in sort of the life cycle for getting your model into production, that would be Bighead Service. So the idea with Bighead Service is to manage all of the different versions of your model, maybe the different experiments that you have, or you can imagine that, say you have a model that needs to be trained weekly, all of those versions of that model are stored in Bighead Service. And it's got this nice convenient UI where you can go in and click deploy on your model, and voila, it's in production. And kind of, for a lot of users, we're hoping that, they start with their notebook, they go into Bighead Service, they hit deploy, and end of story. That's sort of the happy path, of course. And maybe you don't have to go even further than that, but of course things do go wrong. And when they do, Bighead Service also kind of serves as a portal into some of our model debugging tools. And those are more related to how we run our models in production. So the next pieces in the process are to actually get your model into production. So say you've got a model that takes an image of, like a listing photo and predicts whether it's a bathroom or not. And you need to be able to do this live in real time in production. Maybe it's hooked up to the Airbnb website, and you want to, when a host uploads a listing photo, you want to see if it's a bathroom to ask them something like, how many towels are there? Do you have a hairdryer? Little details like that. So say there's some kind of feature and you need just sort of a live prediction. That's where our component DeepDot comes in. It's just designed to be scalable, offer like a REST endpoint for your model. And that's something I think that's pretty standard we've seen across the industry. And then we've also got another productionization component that's called ML Automator. The idea here is to automate batch training and batch inference. And I think at Airbnb, maybe more than other places, batch inference is actually a pretty common thing. So there's a lot of times where you don't really need a live score. You just need to kind of backfill a lot of predictions or scores across your data. And so that's where ML Automator comes in.
And so when the developer is working in the Bighead Service interface and they click deploy, that's kind of pushing the model to deep thought, deploying it out on some actual machines and exposing the REST endpoint, and then they can build that into whatever they're trying to use the model for.
Yeah, exactly. If they have their model set up for live inference, then when you click deploy, it's just like deploying a service at Airbnb, right? It's kind of a new version of that service that's going out there, and that endpoint is now available. And, we do some things to try to make sure that that endpoint stays available for, spikes in traffic, or, potentially if that endpoint, that particular model needs a lot of memory, maybe to load a bunch of parameters into memory. So we do a lot of fine tuning there to make sure that more or less we kind of hide that away from our users who don't necessarily want to deal with the details of scaling their model.
Right.
And hopefully, since we're leveraging Kubernetes for that, we're hoping that we can really get some of the benefits of potentially auto-scaling algorithms there.
And has that worked well so far?
Yeah, Kubernetes has been definitely working well so far. I think auto-scaling is a little bit trickier, but that's something that right now we're just kind of getting into.
Mm-hmm. And are you kind of finally managing GPU requirements and things like that a given model might have, and placing those on specific pods or workers in the Kubernetes environments?
Yeah, definitely. So when we ask our users to specify their model, we ask them to specify their requirements for computation upfront. So that includes like memory requirements or number of cores or potentially GPU. And then we use that throughout the rest of our system to make sure that their model runs in environments suitable for their resource requirements in production.
I think earlier in the conversation, you've mentioned experiment management and things like that, but I don't think that came up in Bighead Service, Deep Thought, or ML Automator. Is it someplace else in the system?
No, actually, that's right. That's right built into Bighead Service. So,
okay.
I think that like this whole process of getting your model from prototype and clicking the deploy button and it's in production, that's great. But it's actually kind of scary, just getting your model into production with just a quick deploy. Is it ready? Is it predictive? Do you know whether it even works or not?
Right.
So that's where Bighead Service offers a whole lot of kind of introspection tools into your model. And, like some of the examples of that, if we wrap a particular library called, like, let's say XGBoost, we're able to produce a lot of details about the trained model that you have right from XGBoost. You can, of course, like, get details like ROC or PR curves. And you can also, for XGBoost, get feature importance information. And both of those types of information, both the actual performance of your model and the explainability of your model, that's really important before you click deploy. So we try to surface that to our users in Bighead Service. And of course, all of these tools that we have, particularly visualizations around this, they're all available in your notebooking environment. So we kind of use the visualizations that we see people doing in their notebook environment, and the most common ones, we kind of elevate them to the status of being incorporated into our infrastructure if they've kind of reached that point where we really see everybody doing this all the time. Or we might be thinking, you know what, feature importance, that's probably something useful that everybody should see. So we'll just automatically incorporate it. So this is all built right into the UI.
Are you doing anything in Bighead Service or ML Automator that is doing automated hyperparameter optimization?
So that's kind of an area that we're hoping to get into right now. The training phase is, and especially hyperparameter optimization, that's sort of left to the user way at prototype time. But one of the things that we want to do with BigQ, which I mentioned before, is offer hyperparameter optimization. And I think that part of what we need to do here is just have people specify their model to us in a little bit more structured of a way than, all right, here's a Python function that trains my model, for us to be able to do something like hyperparameter optimization. So once we have kind of better adoption of that, then we can move on to that next level of abstraction on top of this, where we can automatically train your models. And that includes hyperparameter optimization, but also, like I mentioned before, using like advanced training algorithms, whatever you need.
Yeah. So one of the other platforms in the Bighead ecosystem is Zipline, which handles a lot of the training data, pipeline, data acquisition. Can you talk a little bit about that?
Yeah, sure. So This entire process that I mentioned, going from prototype into production, there's a lot of ways that it can just go wrong on you. And what we found is like consistency across the board is really key. So in addition to the four components I mentioned already, we've got three other components whose job is purely just to maintain consistency. Some of that is around consistency of your environment and maybe the code that you're executing, the actual logic of your model, and some of it is around data. Now, data is super important for machine learning projects, having the right feature data. And so we created Zipline as sort of a solution for keeping consistency across the board. And I think that, this is probably one of the areas I think that we see sometimes overlooked. And it's definitely a piece that's really hard to get right. But when you do it, when you have a single system that owns getting feature data for the prototype phase, when you're just kind of playing around and you don't, want to wait 3 days for your backfill job to generate all your data, but also having that same system be responsible for materializing your data when you need to train, the entire large-scale model and maybe perform batch inference on the model or even real-time inference with the model. Having one system that is responsible for features, that's really key. And it's a pretty hard goal to get to, but we're taking a stab at it with Zipline.
Yeah, I think one of the things that I remember picking up on in your talk, maybe it was another talk. I don't know if I should attribute this to you or if it was someone else, but there was a comment that someone made at this event about data scientists not wanting to share their features. Do you run into that?
That's interesting. I guess maybe the cultures vary from company to company.
Yeah.
But at least at Airbnb, we've gotten a lot of value out of sharing. Now, of course, there's situations where, it's not so much about wanting to share your features, but, machine learning and features in general, it's all really tied together. You can't really separate exactly how your features are calculated from how your model works. And let's say you create some features and I want to use those features, and maybe you're not quite happy with that implementation of those features and you want to change them down the line. Well, now I've already got my machine learning model in production. That's going to be really disruptive to my flow. So I think that maybe some data scientists might be a little bit more cautious about sharing what they're working on because, as soon as you share something, you kind of need to keep it a little bit more constant. But what we found is that, as long as we're able to appropriately version our feature definitions and kind of deal with it in the same way that you might have a library that you depend on, maybe you depend on TensorFlow version X, but TensorFlow version Y has been released. And as long as you don't upgrade, you're fine. And I think that's a pretty important part of our system. And the way that works, if every single time there's a new version of a particular feature, we had to go and backfill a whole bunch of data up front before you could use it, that would be pretty painful. So this only works when you kind of lazily evaluate your feature data sets just kind of on demand. And that's something that's like a key focus for Zipline.
So how are the features defined?
The basic way that you define a feature in Zipline, you'll define kind of some information about where to fetch the events for that feature and potentially some aggregation that you're going to apply over those events. And we kind of try to model roughly everything as events, but sometimes that's a little bit of a tough fit. And then, so now you've kind of told Zipline how your feature needs to be calculated at any given point in time. But Zipline doesn't know what points in time, you actually need your feature information. So what it does at that point is not much. It just kind of keeps track of that. But then when you come to it and you say, all right, I need a training data set and I need to be able to see my features over the last year, and here's all the particular timestamps I need my features calculated at. At that point, Zipline gets to work gathering all the information it needs and efficiently aggregating everything and materializing your data set. So you can imagine, let's say that you have a page on the Airbnb website and you're trying to predict whether a user visiting that page is likely to book. And you want to know maybe the last 7 days of history. In the last 7 days, how many bookings did that user make? Maybe that's like a feature into your model. So specifying, where you get the information about bookings and that you want a 7-day sum or average or something like that. That's sort of the feature definition side of it. And then the next side of it is when you actually need to materialize your training data set, you actually give Zipline a series of timestamps and say, okay, for these users at these times, give me the information about what their 7-day booking history was. So there's kind of that two-step approach, and that lets us materialize the data only when we need to.
And where are those timestamps coming from? Is this so that you can compare models generated at different times by kind of rolling back the clock and looking at the training data that the models saw when they were trained, or is this are there other use cases?
So I think the way to think about it is the training data set that we're creating, the columns in that training data set are the features that you might define, maybe like your 7-day booking sum or something like that. And the rows are really all of your data points for your machine learning model, right? So say that a user goes and views a particular page, and at that point in time, we want to know what the state of all of these various features were. And we know at another point in time in the future what actually happened with that user, right? Like, did they book or were they just viewing the page? So each of those data points, you can think of imagine you have millions of page views over the course of, some time period. Each of those data points ends up being an input into your machine learning model, right? So
it's the event that actually happened plus all of these features that you think are relevant to that event.
Exactly. So you can think of it as Zipline materializing that data set for you. And there is, of course, kind of the separate question of machine learning model evolution over time and how training data is impacting that. And I think that's somewhat of a higher level problem than just directly the feature data. That involves the model as a whole as well. And that's something that we're hoping that the UI visualization tools in Bighead Service help you do, is to kind of see how your model is trending over time.
But it sounds like Zipline's ability to access training data, relative to these timestamps, could feed into the ability to, it feeds into reproducibility. Like, can I reproduce the steps that went into creating this model, if I'm training it at a different time? And it sounds like having an ability to have having the flexibility to manipulate training data with respect to time would feed into that.
Yeah, exactly. And I think one way to explain Zipline is we like to use this analogy. It's like a time machine for your data warehouse, right? You have all these events that are data points into your machine learning model, and they happen, all throughout the continuous space of time that you have in your data warehouse. But your data warehouse isn't really suited for time in as much of a continuous sense. It's more suited for kind of large scale aggregation. And at least at Airbnb, our data warehouse is very much oriented in sort of a day by day snapshot of the world. And that works really well for humans. Humans can't really process things at a millisecond or second by second level anyways. So we of course need to aggregate it. But for machines, you really need that high precision at every single point in time for your feature data to actually be useful. So having that ability to kind of rewind time and go to any particular point and say, what was the exact state of the world at that moment that my machine learning algorithm would have seen when it's trying to make this prediction, that's really, really valuable. It's actually something that kind of is parallel to what I worked on before in the trading industry, where you want to be able to rewind the clock and go exactly to a point in time and see the state of the market. And then, of course, there's that other part of using your model, and that is actually performing inference live, right? So if you have a great system set up to rewind to any particular point in time, that same system, if it's responsible for calculating your features live right now, then you have that absolute consistency between gathering all your training data and actually running your model in production and creating live predictions. And what we found is that when people don't have one system to do both of those things, they end up kind of doing a little bit of manual ETL in their data warehouse, and then maybe, in their live service, they try to replicate that. And that leads to a lot of problems. Now you've got two code bases doing basically the same thing, maintained by potentially different people. So there's a lot of opportunity for those things to become inconsistent. And besides, it's just kind of wasted effort. So having that kind of single system that encompasses both your offline data warehouse work and your online live service work, that's really important.
You mentioned in constructing these features, you're specifying aggregations that are happening over the underlying events. In the case of, for example, a deep learning pipeline, you may also want to do some standardized set of data augmentation or data transformations, things like that, image transformations. Does Bighead or Zipline support those types of things?
Yeah. And this is actually an interesting question. In general, when it comes to forming our feature data, before we actually go and submit it into a machine learning algorithm, we do a lot of pre-processing to it. And some of that pre-processing is things like I've talked about before, potentially doing aggregations, maybe sums across, several days of data. Maybe if you're trying to get a history of 7-day bookings, like I mentioned before. But then some of it is just extra post-processing that we're doing, imputation or normalization. And we're trying to find, the right place to draw the line where where that actually happens. Does it happen in Zipline where you're materializing your feature data set, or does it happen sort of in your, what we call your model's pipeline? And that means, what's kind of built into your model directly before your data enters into a machine learning algorithm. So that's kind of a tricky balance, but I think that one lesson we've learned there is that if your model is seeing those same features and doing that same sort of imputation or normalization in production, maybe on live queries that it's getting, then that needs to be more built into sort of the model pipeline. Mm-hmm. And if in production, and if you're trying to reproduce something that in your backend data warehouse that maybe the model would have just seen directly from the queries it's getting from a live service, and that kind of belongs more in Zipline. So it's sort of a balance between kind of doing some computation upfront in feature calculation and doing some of it as part of the model. And I think we're still kind of trying to figure that out.
And so for those types of transformations that should happen in the model, we've talked about kind of this Jupyter notebook experience. Is there also some kind of workflow or pipeline engine, or have you thought about and decided against that? Are there templates or a library of sorts that that data scientists and ML engineers have access to? How do you address those kind of abstraction types of issues?
Yeah, this is an excellent question. So In the early days for us, we did something kind of really lightweight in terms of the interface that we provided our users. We asked them to define basically a Python function that trains your model and another one that kind of performs inference with your model. It's just like, hey, there's 2 Python functions, fill these in, you're good to go.
Yeah.
And there's some trade-offs with that. So on the one hand, it's great, with the flexibility. You can really almost plug in almost anything, and it's really simple for people to do, to take what they had already been doing likely in their notebook and just get it kind of more or less straight into production by just kind of filling out these functions. Mm-hmm. But what we found was that was kind of it was kind of lacking. We found that people were reinventing the wheel a lot when they were writing these models for production. They're really redoing a lot of work that had been done before by themselves in another model or by somebody else. So we decided to go kind of add a little bit more structure to that workflow and have them instead create what we call an ML pipeline. It's really kind of just a pipeline of transformations that happen to your input data before its output, and a model, you can think of the output, sometimes it's a prediction, but, really it's just a function that's transforming some input. So what we've done is we've tried to create a really generic interface for just specifying these transformation pieces and plugging them in together in kind of this like really easy to compose way that you can just create a entire end-to-end pipeline to do some stuff like image pre-processing or imputation or normalization, and then have that be just enough structure that we can actually understand a little bit more about your model and do some more intelligent things than we could if we just had a function to call for training. So for example, if we know that your model is a deep neural network and maybe on the back end we've enabled this feature that gives us maybe distributed training or something like that, just having a little bit extra information from our users, that slightly more onerous interface for them to specify their model, that's really useful, that's powerful. But that's definitely a trade-off because our users are looking at that interface and they're wondering like, why do I need to use this? So, I want to just, I already have my model, or like this is really complicated. I know TensorFlow or I know Keras. Can I just use that? So we have to be really careful about adding value in that interface and keeping it really lightweight. And we try to add value, of course, through our infrastructure. But even in the prototyping phase, we need our users to adopt these tools up front. This is something we've learned, and we found that other companies have also come to this realization that those tools that you use to productionize your model can't just be incorporated at that point where you're ready to productionize. They need to be used upfront as much as possible, because that way you'll really lower that barrier to entry into production.
What's the experience or the interface for these pipelines?
Yeah. So you can think of it kind of like plugging in Lego blocks together. You hopefully the blocks that you need already exist. Things like imputation or normalization, and you kind of have an easy way to, I talk about it, we call it a pipeline, but it's really kind of a DAG of computation that's happening on your input feature vector before it produces some output. So really what you're doing, we're trying to create a lightweight way for you to create that computation DAG without having to think too much about the details of what DAGs are. But we create this pipeline for you. And fortunately, I can't, the best way to explain it is really to look at a code sample of how you create a pipeline, but I can try to describe it easily.
That answers the question for me. It was really, is this something that's defined in code, or is there some user interface? And is there some notion of a kind of a repository of steps that I might want to plug in that, I'm doing visually, or do I have to know what those are? And like I'm using a standard library of some sorts, and call them from within code. It sounds like it's the code orientation.
Yeah, definitely. There's several different ways to do things. You could prefer config, you could prefer code, you could prefer, UIs for managing this.
Right.
But what we found is code seems to be the best way to go. A lot of times what we see is people doing powerful stuff like programmatically creating these pipelines or composing them.
Okay.
And I think that's a lot easier with code. And I think that to address the piece about sharing, yeah, of course, we don't want all of our users to be reinventing all of these different Lego blocks. So we have our inventory of pipeline transformations that they can just plug into, but they can also kind of share those pieces that they've created, so that they can easily maybe, if somebody on another team is working on a particular model that is sort of relevant, maybe it's an image model and you're also working on an image model, you can actually go to the UI and browse and click in and see what pipeline transformation components they're using and say, hey, oh yeah, you know what? I actually do need a piece that kind of like resizes my image or something like that. Right. So I'll just go ahead and use what you have. So that was something really important for us to incorporate into our kind of discoverability and sharing aspect of our UI.
Okay, awesome. So for folks that are maturing in their use of machine learning, AI, but don't have a platform in place, are there kind of a handful of core principles that they should be keeping in mind as they start to coalesce different tools into, something that's more coherent?
Yeah, absolutely. So, we've talked to a lot of companies, and they're all on this on various stages of this journey in scaling ML at their organization, right? You've got, the big tech giants like Google and Facebook who are really far along, have been doing this for years. And, I think they're getting closer to that ideal of, engineers or data scientists, everybody feeling like they have ML in their toolkit. But I think Uber is actually coming along on that as well with Michelangelo. Michelangelo is a major inspiration for us. And we've talked to other companies as well who are like kind of going down that journey. And we're seeing a lot of the same problems. I think that two things that I would mention. One is consistency. Be thinking about consistency in all aspects of the lifecycle of deploying your machine learning model. And that's what pieces like the Bighead library that we talked about and Zipline are meant to address. And I think that data is, really probably one of the hardest things to get right. So my other point is about, understanding the value of making sure that data and the entire pipeline leading up to machine learning at your company is really well set up for machine learning. I think that, something that we've experienced at Airbnb is that machine learning is kind of at the tail end of a whole lot of work that's happening upstream. You've got your production services, the databases they use, maybe the data warehouse, and then lastly, you've got machine learning tacked on to the end of that. And so one of the things we've noticed is that there's sort of a butterfly effect. Upstream changes can have a really outsized impact on machine learning. And one of the things we're trying to change is just getting more visibility around machine learning as something that's being used downstream throughout the company. And I think that that's like kind of a broader organizational type problem that you need to be able to solve. Getting awareness about machine learning, what the benefits of it are, and then also having people incorporate it into their workflow and their understanding of kind of like what's downstream. So data is, of course, like very critical and very hard to get right and really kind of unique to every different organization, the types of data that's important to you, the pipelines you have set up for it. But I think there's certainly some tools and best practices that are emerging throughout the industry. I think it all kind of boils down to the this analogy of using some of like the best practices from software engineering that we've accumulated over the decades and applying them to machine learning. I mean, sometimes this analogy doesn't work great, but as with all analogies, but I think that it can kind of go a long way. So making sure that you have a good developer environment, making sure that you have solid versioning, unit testing, continuous build, deployment, monitoring, observability. These are all things that we've kind of arrived on for software engineering, traditional software engineering. And one of the things we're trying to do is just translate those concepts to machine learning. Understand, like, what does it mean to unit test your model or integration test your model? What does it mean to like code review a model, right? Like this is also a best practice for software engineering, but we need to kind of reinvent it for machine learning. And yeah, what does observability look like for a model? So that's some of like in kind of a high level way how we're going about approaching scaling ML.
And we should probably also mention that you announced in the talk that Airbnb is planning to open source Bighead.
Yeah, that's right. So Airbnb, we've got kind of a culture of being a host to our community. And I think that's why there's been several open source projects from Airbnb like Airflow and Superset. And we're hoping to actually open source Bighead as well in the coming months. We're really excited about that. It's kind of something that our entire team has been thinking about since the start, but it certainly takes a lot of work to actually make happen. So we're hoping to get to that in Q1 of 2019.
Awesome. Well, I'll be keeping track of it, and it's an exciting step. Thanks so much, Atul. Appreciate it.
Yeah, thanks for having me, Sam.
All right, everyone, that's our show for today. For more information on Atul or any of the topics covered in this podcast, visit TWiMLAI.com/talk/198. To learn more about our AI platform series or to download our ebooks, visit TWiMLAI.com/AI platforms. As always, thanks so much for listening and catch you next time.